Forces in circular motion reassessment. What we have is a ball rotating around a string in a horizontal circle, so that it's completely flat, circling around. It's got a length L, an angle theta, and the ball weighs a mass M1. So the first thing we're going to do is try to find the tension of the string to find how fast the ball has to be spinning the entire time. So we're going to do the sum of forces in the y direction equals T times sine of theta minus mg. We get that from our free body diagram here. And then we get the tension is equal to mg times sine of theta. We plug in the numbers that we have up here, the length, theta, and m1, and we get the tension is 4.96 newtons. Now what we're going to do is find this radius right here, because we'll need to know the radius, how far the ball is away from the center. And we know that by the radius is equal to the length times cosine theta, because it's on the same side, so it's cosine theta. And so now we're going to do the x component, and we know that the sum of forces in the x direction equals mass times acceleration in the x, and acceleration in the x is equal to the negative velocity squared divided by the radius, which we found here. So sum of forces in the x direction are negative t cosine theta, or negative t times cosine theta, which equals m times negative v squared divided by r. And we want to solve for velocity because that's what we're trying to look for. So the negatives cancel here, and then you can swap everything over to one side, and then you divide by, and you take the square root to get velocity by itself, and plug in the numbers, and the velocity is 6.16 meters per second.